Hi everyone, and welcome to my tutorial series again. Up until our previous video, we looked at how to run the entire simulation and generate simulation outputs for different random seeds. And then we looked at how we can collect or rather append them all to a um, single CSV file that we did using collecting everything to a pandas data frame and then writing it to the disk as a CSV file. Now that we have this file, which contains all the or results for all the simulation runs, now we can start analyzing it. Let's say in this case, we are going to visualize it through a meaningful chart. Right. So we'll see how we can do that. And if you feel like this content is useful, please consider subscribing to my YouTube channel. Right, so let's dive into the exercise. Now for this, instead of a Python script, I'll create a Python notebook. Right, let's say num3. Uh, sorry, Python notebook. Right, so for this notebook, we will let's say oops, this has to be Python. Right, so let's so I'll load the pandas so that I can read the CSV file. And then I also want for visualization Seaborn, which I may have to install. Also, let's get this is for fine tuning the plot. NumPy, I'm not sure whether we need it. Let's see whether we'll need it. In that case, we'll use it. Also, yeah, let's use OS. Right, let's see whether these libraries are there. Okay, we need to install something to work with the IPython notebook settings or set environment. It takes some time than expected, but let's give that time. Um, but I guess you can skip this video for 10, 20, 30 seconds and then continue to the next part where I do the actual coding. Right, so while it's getting installed, I guess we can do some other stuff, right? Now, for example, I can set the working directory. Let's set the working directory to this process result, right? I guess I need to get the full path. Let's fix that. and then we can, yeah, so then we can read the files, right? So say, let's say our emission output. So relative to this path, our CSV is in here. So I can straight away say, okay, this is a markdown file. So yeah, so I can straight away say emissions all runs dot or rather base CSV. Right, so let's say it's take a bit time than expected. Yeah, I think now it's fine. So first these libraries are being loaded. Yeah, so we don't have Seaborn. Okay. Okay, the OS is also not loaded. Fine, so we'll install Seaborn. Yeah, let's give it a minute. Guess it's being installed still. Yep, that's it. So I guess we can run this without an issue now. Yeah, it's done. Yeah, so this is now in a pandas data frame, right? So you can see random seed and everything, and also, I mean, this is we added manually, but rest of them are calculated through the simulation, and now we have collected them nicely. So from this point onwards, I'll be using some pre-coded setups. I'll copy paste some stuff just to save time, and then we'll see how we can. I'll explain as I do it. Right. So this is our emission outputs. Um, so let's use the columns. Let's keep some columns, right? Not everything. Yeah. So we'll keep some columns just because not all the things are mandatory. I mean, we can only keep even one column, right? I guess these are also not necessary because I'll be analyzing only, or rather visualizing only, the carbon dioxide absolute value. But you can keep it because if you feel like you want to change these, then you can feel free to do so. So I'll keep it because it doesn't do much harm. So now we have a reduced data frame, right? So if you look at now, we have only the required columns that are needed for our analysis. Right. So then we can start visualizing it. I mean, these are in milligrams, right? So we can convert it to kilograms, right? So right. So I'll be taking this right? Carbon dioxide absolute value. This, and I'll be adding a new column to my pandas data frame, dividing it by million so that I have the required in required units, the outputs. So let me add a part here saying data preprocessing, right? That should be clearer then. And then I can start visualizing the data, right? So if needed, you can convert the other ones as well, right? So let's say, for example, carbon monoxide absolute value, also similarly, you can convert it to kilograms by dividing it by million, right? So let's visualize the data. Now, here I'll be using the figure axis method in matplotlib, right? So let me use this and let me use plt.show. So then you have an empty canvas to play with, right? And then I can gradually add the stuff that I need. So let's add this, right? So on the x-axis, I'll use interval begin. On the y-axis, I'll be using the calculated carbon dioxide emissions in kilograms. So if I do this now, all right. So what's the error? Okay, there's nothing called scenario. Okay, that will be something we can remove and run this. So now you see the carbon dioxide emissions in kilograms. You can see now the thick line over here is the kind of the average value of those multiple simulation runs, because we have now for each timestamp, each time interval begin timestamp, we have 12 records, right? So it shows the average and the spread, right? In the band shows you the spread, and the thick line shows you the average value. So that's how we can read it. And then I'll add the time steps for that. Now for that, I need numpy. Import ISP. All right, so let's add that line so that now you have instead of these simulation time, we have the actual, let's say the clock time, right? Okay, it's not added yet. I need to do this for that. Right, I'll set the x-ticks. Right, so now we have the time, and the y. Let's add the labels. Right, so now we have the y label is emissions in kilograms, and time is in on the x-axis. You have the time, right? So you have everything nicely written. And also we can add add a bit of a rotation to the x-ticks, and add a title, right? So stuff like that you can do. Yeah, so let's add those as well, and add the title. Now here I have added the carbon dioxide as a the letter 2 in as a subscript, which can also do in this one as well. In addition, I have rotated the x labels by 45 degrees, right? So if needed, we can do the same to this one as well. I'm sorry, it's a R, and then it has to be this, right? So then everything is nicely formatted, right? So now this kind of a chart you can display to, or rather present to someone, and share your findings of the simulations, right? So yeah, so that's it for this video. In next video, we will see how we can simulate another scenario, different scenario, and go through the same process, and how we can visualize the outputs on the same chart. Right, so we'll see you on next video. Thank you for watching this video. And if you like this content, I'll again remind you to consider subscribing to my channel. Thank you.